So in week 6 or in week 5, you learned how to simplify radicals, or you reviewed simplifying radicals. This is week 6, and we are going to work on simplifying radicals one more time. However, this time we need to make sure that we do not have a radical in our denominator. We can't have one in our denominator because if we were to add it as fractions, then we're not able to add them equally. It doesn't work out. So we always do what's called rationalizing, where we get rid of that radical. Now, I want to remind you before we start that the square root of 3 times the square root of 3. When we take the square root of 3 multiplied by itself, it just becomes the number inside my radical. So the square root of 3 times the square root of 3 is just 3. Just like that, the square root of 12 times the square root of 12. Oops, I meant to write 12 and thought 3. The square root of 12 is just 12. Notice we essentially got rid of that radical. We're going to do the same thing here. So for number 10, we have to get rid of that radical, that square root of 12, which means that we're going to multiply it by the square root of 12. Now, if I do something to the denominator of a fraction, then I have to also do it to the numerator. I have to keep it equal, which means that I multiply both top and bottom by the square root of 12. Remember, when we're multiplying radicals, we multiply the numbers on the inside and we multiply the numbers on the outside. So our numerator becomes 3 square root of 240 because 12 times 20 is 240. And our denominator becomes 2 from this 2 times 12 because the square root of 12 times the square root of 12 is 12. Now, I'm going to rewrite this as 3 square roots of 240 over 24. We are not done because we have to simplify our radical. If you remember from last week when you simplified your radical, the easiest way to do it was to take the number inside my radical and divide it by 2. That's 120. So I'm going to look for the perfect squares that are less than 120. I know that 11 times 11 is 121. So my perfect squares that start below 120 are 10 squared, which is 100. That does not divide evenly into 240. 9 squared, which is 81. Again, does not divide evenly into 240. 8 squared is 64. I'm pretty sure that also does not divide evenly into 240. 7 squared is 49. That does not divide evenly into 240. 6 squared is 36. Also does not divide evenly into 240. 5 squared is 25. Does not divide evenly into 240. 4 squared is 16. Pretty sure that does divide evenly into 240, and it does. So we are going to have to rewrite this square root of 240 as the square root of 16 times the square root of 15. 15 times 16 is 240. I can take the square root of 16, that is 4. So this is 3 from this 3 times 4, because the square root of 16 is 4, square roots of 15 over 24. Now I'm going to rewrite it one more time. I always keep rewriting. Without rewriting it, you end up skipping or missing something. So I don't think you're going to, can you see this? So 3 times 4 is 12, square roots of 15 over 24. Now we can reduce that. Hopefully you can see the 24 is twice as much as 12. So that means that I'm going to end up with the square root of 15 over 2 because I divided both of them by 2. This one canceled and became 1, and this one was 2. So this is my final answer. Notice there's a couple of steps here. So your first step is in blue, where you're multiplying by the number that's in my denominator. We have to rationalize it. We have to get rid of that radical. The next step is where you have to simplify your radical. And then the third step is in green, well, green to blue, where you have to simplify your fraction.